My name is Damle, founder of Helium. I'm sort of a serial entrepreneur in the AI and healthcare space. Usually, preferably over a glass of wine, but however and whenever is good. Um, Today, I was asked, what can we talk about that's actually interesting, and I did not know what level of technical sophistication or data sophistication people are. So I tried to make it somewhat balanced, but some people here obviously are quite quite data literate, and other people are more on the business side. But let's hopefully have a conversation. Before I start, who's familiar with the phrase foundational models? Awesome. Okay, then hopefully this will be interesting for many of you. Let's get to it. I think today's panel and obviously today's conversation really highlight the fact that we are living in an extraordinary world today. Our world is fundamentally changing on a day by day basis. And we sort of see this in all sorts of ways. I mean, first of all, SpaceX is awesome, but even more awesome was the fact that AI was really key to go and making this actually possible. And go through and think about self-driving cars. And I know that at least I remember watching the Jetsons, so at the very least, this was always something of interest, right? And it's starting to become a reality. And part of what I talked about when I guess we were asking the question of what gets you up in the morning every day, what's exciting about it, healthcare or AI, I should say, is really the ability to unlock our creativity, right? And that's actually happening. And then also towards the point of robotics and the rest to dramatically increase the simple things, simple logistic things, such as supply chains and warehouses. And, since we are talking about AI biology, obviously AlphaFold and a variety of these things obviously are key how they're changing the actual day. And this is an example of a foundational model, and we'll get into that. So are many of the other things that we're talking about. And each of these things actually was made possible by some foundational models. And to say the least, I'm sure almost all of you know these companies, and there are many, many more towards what Kai showed, 800 of them literally now available, right? And towards the tune that, once again, Kai mentioned, there always $600 billion or whatever was invested, some crazy amount. Sorry. But to say the least, AI in biology is not a new thing, right? Even back when we first had the computers, it was already the first question: how can we apply this to ourselves? Right? Though obviously, we walk around with our smartphones, which are basically supercomputers, which dwarf anything that was possible back in the 1950s. So they just didn't know how to have the computational capabilities. Definitely the ideas were starting there, right? And we went to the 1980s where we did expert systems, a little bit less so of learning. There wasn't vast amounts. There wasn't billions of data points or trillions of data points, right? We were having to make that stuff up. And then you go into obviously the 1990s when we starting with the genetic data and EHRs, but obviously now much more prevalent. 2000s neural nets, deep learning. Now we're starting to get something very exciting where modern biology starts meeting that. Now we're starting to get to the sort of what I would sort of call sort of the days of foundational models and AlphaFold and Meta. Interestingly enough, Facebook, right? ESM also on the protein folding side. And what's interesting is the expanse of where it is being applied. It is not just I'm looking at protein folding. I'm looking at whatever. It literally is touching every area of biology as we know it today, right? And towards that, now is exceedingly interesting because of the potential of what is called foundational models, right? And the computational scale. We talked about the capabilities and what makes AI possible today, but actually interesting that only now can we actually use this as today's microscope. That's sort of a phrase that a lot of people uses. AI is today's microscope in terms of biology. But as I was mentioning, foundational models, what are they and why do they matter? Well, it's basically, as we talked about, generalizing highly complex patterns. I presume everyone here has used ChatGPT in some fashion, had long conversations on the weekend. Oh, wait, maybe that's sorry. Um, but it is fascinating for a system that actually has no reasoning, no actual model of a situation. The complexity of output and the interactions that we can have are quite startling. And that's purely from learning patterns from an ungodly amount of data, right? But with that starts unlocking some very interesting ideas and possibilities. And so, especially in biology, that starts allowing us to really think about new questions that were very hard to answer. And it's in some senses a vehicle or means by which how can we put our knowledge or the data that we have today to actual work. Now, we all talk about PubMed. It's an extraordinary resource. I'm sure none of us have read all of PubMed, right? And you can sort of expand that to all the data available on the internet, the good, the bad, the ugly, the who knows what, right? The question is, how do I put that to work? How can I leverage that to help me answer my question today? How can I use it to help me reason or think about something, right? What is that assistive tool? So foundational models are really models which have learned how to connect concepts or ideas that we may not have done so. That's what's really exciting about them, right? We can ask it, tell me about, I don't know, vertices and the humerus bone, and something will come out. Whether or not it makes any sense, I have no idea, but we can ask the question. And it's up to us to be able to evaluate the accuracy, the quality, etc. But something will come back that's there and somehow connected, right? We talk how do specific gene variants influence protein interactions, right? You can actually specific gene codes or SNPs there in particular proteins, and it will come back with something. Now, before you would have to do a bunch of keyword searching, you would have to go through and read up 20 different articles, think for a long time, have a cup of tea maybe, and then try to start answering that question. Here, you're immediately starting to get something to reason against, solving the null sort of emptiness question. And that's sort of the power of foundational models is it allows us to take a wide expanse of data and start applying that to very specific problems that before applying that data would have been very hard. You know, recently I was talking with someone about how do we integrate all these different systems. And before programming, and I would talk techie JSONs and Excel, and XML files and also CSV files, whereas the means by which we would connect system A to system B. Interestingly enough, with these systems, it's you actually the language of interaction or interoperability actually is English. It's a human language. They may have a different way of modeling. You have, I don't know, there's a bunch of them that I'll show in a second. But the way in which you would communicate from one to the other is actually not in a programming language. It's actually as how we would communicate with each other. So it just becomes a very interesting way and opens the door for many ways to combine things that we did not have before. And once again, I put a couple of these things like Anthropic and ChatGPT up here because actually they've trained and learned on huge amounts of actual biological, medical, and healthcare data as well. Not that, by the way, the results are accurate. We've done lots of QA on this, question mark. But it does allow us a vehicle to see how foundational models are starting to be applied, right? So really what I want to talk about was sort of two things was foundational models are built on sort of two things. And this is true of sort of AI in general. If we talk about today's conversation, we always talk about the quality of the data. And then there's also what is the architecture of the AI. Kai was talking about reasoning in a different format of an architecture. A lot of people think about deep learning. A lot of people think about large language models. A lot of people think about statistics and our good old logistic regression that happens to still be of value today, right? And when I go think about that, what actually can, I would say, defines the magnitude of the impact is the architecture, right? and this is towards what people were talking about earlier of to train one of these large language models requires huge amounts of computing power, huge amounts of electric power versus something that we do with much less, power, etc. We're able to still arrive and learn those things, right? We talked about how does a baby learn people's faces and all sorts of things of that nature. So the architecture really does matter. But where there's a huge amount of opportunity is actually in the quality and type of data, right? So if you were to look at how do I build a foundational model, or even more point, fine tune or build on top of a foundational model, the question you need to ask yourself fundamentally is what data do you have? What is the quality? We talked about that a lot. Garbage in, garbage out is never more true in AI than in anything else. Sometimes, who knows, even then, right? Um, so when I think about what it takes to be successfully build a foundational model, meaning that something that has higher, basically multiple use. Obviously, there's the data, and we talked about that as well earlier. We talked about the computational resources, and then I think the other equally important thing is the people and the expertise in the domain. Many people are amazing data scientists, but then they have no understanding of the biology. And then you have people who are extraordinary in the biology and have no understanding of how actually AI works, right? What you really need is to have the combination of the two. I remember back in the days, one of my previous companies, Lumiata, there was a big internal argument between the data scientists and the clinicians about the word at risk. Because one person at risk means greater than zero. And the clinicians, if you actually look at it, it's greater than 70% likelihood. But neither of them were able to get to this level of understanding in that conversation. Right? And it's an issue of how do we communicate? How do we translate from one domain to the other? Having people who understand that crossness combined with having access to the data. And this is another part of people, as another example. How many people are familiar with NDC codes, National Drug Codes, here in medical data? So for those who don't, this is how all your medications are coded in the US. And a lot of people have electronic health records or other data about patients, and you'll have national drug codes. Now, for some simple things like metformin, it has about 3,600 some odd different NDC codes. So obviously, if you're trying to talk about your signal in your data, it's highly fractionated. But if I do something simple like extract out what are the actual active ingredients, suddenly I've aggregated a signal. Suddenly something makes sense. And so that's an issue of understanding the domain, crossing the data. So what knowledge can be used to help me understand the prompt today? And that's also, once again, having a much wider breadth of data than you may initially think available and applied and learn from, that you're able to start creating connections that otherwise were not available. So, and today we talked about proteomics, we talked about metabolomics, we talked about genomics, transcriptomics, just a few of the sets of data that we're talking about. And one of the challenges that there is in biology is how do I connect all of this? Even if I go to all the research papers out there, I still don't actually have all the data that tells me how do all these things connect, right? And part of that is because, well, we don't know. Part of that is because the data is not represented in different ways that make sense, right? And so this, I would say, especially for foundational models in biology, this is where your challenge is going to be. How do I start connecting all the different type of data that's relevant so that I can model, I can represent my data in a way that makes the most sense? And so what I wanted to posit here today and sort of getting at in the very beginning was what's actually necessary to be successful in building these foundational models. I would advocate is what I would call a data plan. right? And I would say this is just true for AI companies in general. What is your data plan? How it is, and it's like how you think about your business model. Why is it 1 year from now you'll have 10x the amount of relevant data that you have today? How is that allowing you to put a differentiated, all the way from a diverse set of cell clones, right, to expanding the set of proteomics data that you have to otherwise, right? And so what I want to do is just sort of talk about sort of 5 steps towards the data plan, and sort of maybe hopefully start that up as a point for discussion. The number one, how many times have you gone to a company and say, so what's the vision for your data? Which is a slightly different question than what is the vision for your business? They should be aligned. That's one of the key things that I would ask. Because without like this, people say most companies will be generating data. But if I think about an AI first company, data is what is the fuel for building the product, building the service, for building the business. It is not something that you generate. Like if I'm a manufacturing company, right? I'm manufacturing toys, for example. I have lots of data. I'm generating that. But it's not what I'm actually using it to build my business, right? So it's sort of a different vantage point, different frame of mind. Beyond that, obviously, you want to talk about how you want to measure that and what KPIs you have specifically around your data. Talk about quality. That's an important sort of KPI for data. Well, how do you measure quality, right? And then how do you think about what is that value that's actually being generated? The next thing, which I find surprising enough, so if you go to a company like GE or any of these large companies, no one has any idea what data they have. Like they have hundreds of databases with data sitting around, but no one has any clue what's actually there. So then how do I know what to put to use? I have no idea, right? So really having a clear view of what actual data assets you have, what is the inventory, what did they say, where is it, and then how and whom do it get to access that? What's the governance, right? We talk about healthcare, we talk about privacy, right? These are important things. How does that actually all play out? And I have today's data, but how do I acquire new data, right? And one of the things that I talk to a lot of people about is scorecarding your data. What is the value of this piece of data? How much effort is it to get it? And what is the quality it's going to have? And what is the longevity it's going to be? Right? So when I think about what data I may want or may use, how do I scorecard it? And then how do I think about where they may be? How do I do that? And who can I work with to go ahead and get that data? Number 4 is data architecture, schema, and representation, right? This sort of gets a little bit different, but I'm sure at least, well, unfortunately myself, has spent hours upon hours accessing databases, doing this, looking at schemas, understanding how the data is actually modeled. And one of the key things is you want to make sure that you are modeling your data in a way that's easy to use, right? So and the last part of that is how do you combine that, as we talked about earlier. And then really one thing I want to double click on is basically how do we represent our data for AI, right? So if I talk about normal neural network and I just want to apply that, what's my feature set? How do I get my feature vector? How do I push that in? And I realize I'm speaking very techy here for a minute, but fundamentally it's very tabular data, right? Think of that CSV, right? It's sort of a mental picture. Right? Versus a large language model, I want to figure out how do I create articles and papers and subsets of data and feed that in. Because if I try to fit in a bunch of CSVs to a large language model, it's not going to be very useful because it's not built to deal with data like that. Right? So understanding how you represent your data for what architecture is going to make a significant difference. Right? And so this is actually where a large amount of time or thought, I would say, needs to be spent. Because this is going to dramatically swing how much value you're going to get for the efforts that you're putting in. And lastly, this sort of connects to the issue of people. Do people understand sort of the language of data? Like I remember I was talking with a VP of engineering for a relatively large company. and I mentioned, well, we'll send over the JSON, and for all of you, that is a data format. For him, I did not expect the following question, which was, "Who is Jason?" And I felt very sad. See, exactly. So, right, and I'm like, okay, then, I guess I'll have a different form of conversation than I originally thought. Um, so, how do you build that conversation, that culture of data, where people at every level can talk about it and ask about it and interact with it in ways that are meaningful? And that is part of the power of things like large language models. The allure is, well, we all speak English, so in effect, they all can now get access to data. However, I would like to question large language models are not analytic models. Be very careful of suddenly asking them to do, like, please give me the sales projection for this. You may not really be getting a validated answer at the end of the day. Um, and really sort of these other things of, how do I talk about biology or proteomics with respect to a data scientist and otherwise? How are they going to understand that context? How do I bring these people to speak a common language? Right? And then how do I go ahead and make that enabled at scale? So when we put a data plan to work with foundational models, kind of amazing things can happen. And we're starting to see that. I mean, already with things like AlphaFold and things of that, you start seeing, okay, there are now ways in which this is truly accelerating development, right? Transportation, mobility, communications, healthcare, right? And, I would posit that you should run your data like you run your business. And a lot of people don't think of their data like, I've worked with companies at the end of the day where, they're engaging with consumers on the internet, but yet they cannot track and understand every single touch point they had with that consumer, which is like saying, like, I don't know who walked into my store, what products they want. Well, that's going to be kind of hard for you to figure out what to do next, right? So really thinking of this as sort of the core thing from a sort of frame perspective, and also sort of that key ingredient for our foundational models. So just want to talk and obviously open up the conversation. So please.